part one if you're starting for the chemistry unit 1 lessons 1 through 6 and unit 3 lessons 1, 2, 3 midterm this week. So this is gonna be part one. There'll be some questions. It's only a little bit of questions and some answers. So let's get started right away. So here it says no basic properties of identify matter. So physical properties is like mass, density, state of matter, malleability, ductility, shape, size, color. And the chemical properties will be like flammability, combustibility, and reactivity, like something more like chemical. What is density? How is it calculated? How can we test density using water? So mass per unit of volume. So mass divided by volume is how you calculate density. So you divide the mass of the object and divide it by the volume of the object. And in some place you would calculate the water displacement of the object. So basically in density you would calculate mass divided by volume, you would get your density. Compare and contrast physical and chemical properties of matter. So it also says, so for the first question it said to identify matter. Now we gotta compare and contrast physical and chemical properties of matter. So here it says physical properties: mass, density, state of matter, malleability, ductility, shape, size, color. And it's kind of like the same answer for the first question, but it's also comparing, contrasting. For chemical properties, flammability, combustibility, and reactivity. Alright, this define physical and chemical change. So physical change basically is like an appearance of an object, but not the identity. So it's kind of like something more physical. It's not nothing. It does not change into a substance. It's just an appearance. For example, flipping a coin would be like a physical change. But in the chemical change, the identify changes into a new substance. For example, flammability, combustibility, and reactivity. So that would be for chemical change. And also the next question would be give 5 examples of physical changes and 5 examples of chemical changes. For physical examples, the density of water is 1, the banana is yellow, aluminum foil is malleable. So the density of water is 1, the banana is yellow, that's physical, nothing changes, but it's a physical change. The aluminum foil is malleable. And for chemical examples, the examples would be like paper will burn, it will most likely change into something else. And baking soda will react in the vinegar. So that's the chemical examples. What evidence can you have that a chemical change occurred? There are 5 common ways. So chemical change occurred when gas is produced, the color is changing, odor, smoke, light, heat produced, sound, fizzing, and bubbling. So those are the common ways. So gas produced, color change, like it's changing colors, odor, smoke, the light, the heat is being produced, the sound, fizzing, and the bubbling. Okay, so here's a little bit of a explanation kind of question. So when given a picture of the particles of a solid, liquid, and gas, so you gotta identify each one based on particle arrangement. So here, let's look at the graph. So solid starts to cool. So here it starts to warm, but when you decrease it, it's cool. So when it increases, it starts to melt. then becomes liquid, then boils, and then starts to get even warmer, and it turns into gas. When it freezes, it cools down, condenses, cools, then freezes and cools to become a solid. So from a gas to solid, that would be called. What do you guys think? Let me know in the comments. So let's go into the questions. How do the particles in solids, liquids, and gases move? So how do they spread? So solid particles are tightly packed together. They vibrate in place, so this is a solid. It's tightly packed together. They also vibrate in place. And there's volume and shape, and they are definite. For liquid, right over here, are loosely together. They slide past each other. Volume is definite, but the shape is indefinite. It does not create a shape. But there's volume that is most likely to be definite. Okay, next one. For gas, particles are spread apart and move freely. And volume and shape are indefinite. So volume and shape are indefinite. So they're spread apart, they move freely. Volume and shape are indefinite. For plasma, which is not on the graph but it's something else, the particles are charged and move fast. Volume and shape indefinite. So they're charged like electricity. It's like a plasma. Thunderstorms could be one example. And other kind of examples that are charged or move fast. You will find out later. So the volume and shape are indefinite. It's basically charged and moves fast, so it's indefinite. Which will have a definite volume shape. So basically, solid does have a definite volume, and it seems like it also has a definite shape. And it also seems like the liquid also has definite volume, but it does not have a definite shape. Because they are loosely together, they slide past each other, so they basically move a little in liquid. Okay, next one would be to know the phase changes. Freezing, so here it's on the graph right here. Freezing, melting, evaporation, condensation, and sublimation. But first we're gonna know freezing would be cooling down, melting would be like getting hot, evaporation would be here it says solid warms, liquid warms, boils, gas starts to get warm, but when it decreases it cools down. Condensation would be like in the middle. Sublimation would be like solid to gas. So we talked about the image, so that's the question. And this is the last one. Then the video's over. So what happens to energy of the particles during each phase change? So speed, temperature. So the first one says solid changes into a liquid. Solid changes into a liquid. Melting particles speed up and break away from each other. So when solid changes into a liquid, it's basically speeding up, breaking away from each other. So yeah, so that's the solid change into a liquid. So they speed up, break away with each other. Liquid changes into a solid. So it's freezing. When liquid is moving, it starts to turn to solid. So it's freezing. It's getting colder. The particles slow down and clump together. They slow down and clump together. Liquid changes into a gas. That's obviously going to be evaporation, because the particles speed up and break away from each other. So they speed up, break away from each other. That's evaporation. Liquid changes to a gas. Gas changes to a liquid. It's known as condensation. So they slow down, come together. Say the gas in the sky turns into a liquid, then that means it's slowing down and clumping together. And lastly, for solid, changes directly into a gas. That is known as sublimation. And that was the answer that I was trying to ask from the last few questions. And basically because the particles speed up and break away rapidly. So this is what it does. This is sublimation. Solid changes directly into a gas. And this is the first part. And hope you guys understand. Hope you guys like the video. And I'll see you guys later. Bye.